Okay, there, another look at simultaneous equations and looking at about the intersections between, say, a straight line and a quadratic, for instance. And here we've got a quadratic. Y equals x squared minus 2. Notice the familiar for what's called a parabola. And the parabola is this U shape, and then we have a linear expression. I'm saying y minus 2x equals 1, but you could equally write that as y equals 2x plus 1 if I just moved the 2x onto the other side, and that's linear because it's in a straight line. And we're interested in the fact that this particular one crosses in two places. You can see it crosses there and it crosses there. But I will say to you that it's not always the case. So let's have a look at this one. Y equals minus 4x minus 1. Now I just know what that looks like roughly. I don't know exactly, but it crosses at minus 1. There, that's what this tells me. If you remember your y equals mx plus c stuff, that tells me the c is minus 1, so that's why that's there. But it's got a negative gradient of minus 4, so I'm going to guess it looks something like that. I don't know exactly. This one's y equals x squared plus 3. Now, 3, looking on my scale, something like that. Now, the problem is you don't really know what goes on here. That carries on. Now, it could be x squared plus 3 does that, and in which case they never cross. Or it could be they go like that, in which case it crosses. And I suppose what I'm looking for is, or it could even cross again, I suppose, as that curls up. It's how many places this crosses in. And the way we are going to do this is we're going to use something called the discriminant again. We've seen the discriminant before. The discriminant, now there is a new symbol for the discriminant, but it's basically b squared minus 4ac. And we often use this triangle for it. Discriminant then tells me about the solutions, the number of them. So let's go about looking at this. Now it says y equals x squared plus 3, y equals this, so I can just set them equal to each other. So let's do it. Minus 4x minus 1 is equal to x squared plus 3. And the same thing applies. You move everything onto one side. So put them all over there. X squared minus 4x becomes plus 4x. Minus 1 becomes plus 1, plus that 3 is plus 4, and that's equal to 0. Now if I find the discriminant, this symbol is a discriminant symbol again, I'll remind you that, b squared minus 4ac. Let's see what a is. A equals 1x squared, you see. B equals 4. C equals 4. So if I find the discriminant, b squared is 16. Minus 4 times a is 1. Times by c is 4 again. Oh, look at that. 16 effectively minus 16. That gives me 0. Now you should recall when the discriminant equals 0, there's only one solution. The rules apply from what we did before. If the discriminant is greater than 0, that tells me I get two solutions. But if the discriminant is less than 0, I get no solutions. So this is what we've seen before. So I know they have one point of intersection. So this is what I was talking about before. What does it look like? Well, I think it looks now like that. They definitely cross, but it seems to be the case that they only cross in one place. It says, hence find the coordinates. Now this is where I meant to solve it. But I now go back. I know there's only going to be one place, but I now go back and do it. So if I take that one there, I can use the equation solver, or I can just factorize it. I reckon it's x plus 2. X plus 2, and of course that's the reason why there's only one solution. It's the same bracket. So the only answer is x equals minus 2. I need a y value. It's probably easy going in there. Square it is 4, plus 3 is 7. So I think the coordinate is minus 2, 7. Doesn't look much like it on my dodgy graph, but there you are. So this is the actual graph. Minus 2, 7. It says there's only one point of solution, one point of intersection, and it's all because of this discriminant is equal to 0. So this, when it is only one solution, in these situations, we call it a tangent. It just touches. So this is an important word. You see it when you do work with circles as well. This is a tangent, just clipping this curve. There are plenty of occasions when this is the method of, that we will use to determine the number of solutions. And notice it says here, use substitution rather than elimination. It's a much better method. Here's classic, y equals something. Now notice they've got it written for me in that form. So it's just crying out to go into this equation here. So I'm going to write x squared, not y squared. No, I shall write x plus 2 all squared equals 9. So it wants me to work out the number of points of intersection. It doesn't mean solve it. It means determine how many solutions you'll get. And to do that, we use the discriminant. We use this discriminant, which is equal to b squared minus 4ac. So let's multiply out those brackets. I get x squared here. And when I do this, it means x plus 2, x plus 2. I'm writing it again twice like that, because lots of people forget, and they square the x, and they square the 2, and they get x squared plus 4. But of course, when I multiply this out, I do get an x squared, but I also get a 2x, and another 2x, which is 4x. And I then get 2 times 2, which is 4. So I do get x squared, I do get 4, but everyone always seems to miss out that middle term. Write the other bits, the x squared at the front and the 9 at the end. So what have I got? I've got 2x squared plus 4x. Now you have to make these equal to 0. So 9 moves over, becomes a minus, I reckon I get minus 5. So again, you might as well just chuck that in your calculator, unless you can obviously see it. Menu, go to the A, polynomial, degree 2, and so it's 2x squared plus 4x and negative 5. And I get some rather horrible. Oh, I'm pleased about that, because I just solved it actually, and I shouldn't have done. But I'm pleased I don't have to, because I just got a horrible square rooty thing. In actual fact, it says how many solutions do I get. So for that, I can just go a equals 2, b equals 4, c equals minus 5. And let's just do it. Determinant equals b squared, which is 16, minus 4 times a times minus 5. That's 16. Well, that minus and minus is a plus, so that's really plus 40. 8 4 2s, yeah. So I get 56. And because that is greater than 0, there are 2 solutions. There are 2 points of intersection. What's it say? 2 points of intersection. That's what they wanted. Exercise. So you are meant to do these 3. I'll do the first one for you just to remind you, but then after that I shall let you do a couple. So again, I'll do this first one. Notice it says y equals. So, I mean, this one's better anyway. It says y equals this and y equals that. You can just set this equal that. But 1 and 3 are very similar in as much that it says y equals, so just put that into your equation here. X squared plus 3. Notice it says y, so I write x squared plus 3 instead. Plus the 2x equals 2. Now remember, we don't have to solve it. It just says decide how many points of intersection you've got. So I'll do here x squared, let's tidy this up, plus 2x. The 2 moves over, gives me a plus 1. And I want to see the discriminant found. I want, in your exam, b squared minus 4ac, I want to see it. What's it equal? It equals, well, my a is 1, my b is 2, my c is 1. So it's b squared 4 minus 4 times by the 1 times by the 1. Alright, that's 4 minus 4, which is 0. So this again, because it's 0, there's 1 point of intersection. It doesn't ask me to find out where it is, by the way. Up till now we've been told to find where it is. Here we're not. So can you pause the video, try and do 2 and 3 on your own. Okay, hopefully you've paused the video now, you've got some answers. I'll just do one more, I think, for you. I want to do this one really. This is a little bit of rearrangement, but hopefully you've got this. I just realised that all x squared plus 3, I hadn't sussed that, they're all x squared plus 3. And it's just different lines. And I suppose it's highlighting the fact that the same curve can be intersected different ways. So I'm quickly going to do this anyway. So the first one says y equals x squared plus 3. But then this one, I just want to rearrange this one. Y equals, move these two things over. And I think I get plus x minus 1 from this I can change it into there. So when this says y equals x squared plus 3, yes it does, but put a different way, x squared plus 3 must now be equal to this x minus 1, because y equals y. Okay, x squared minus the x, the minus 1 comes over, plus 4 equals 0. So what's that give me? Again, a equals 1, b equals minus 1, c equals 4. So b squared, b times b, I'm just going to write it as well, b squared minus 4ac equals, b squared is 1 minus 4 times 1 times 4. Oh, right, now that is 1 minus 16 when you do it, which is minus 15, which is less than 0. Now when it's negative and it's less than 0, there's no point of intersection. Now, I haven't done the middle one. It'd be interesting. I assume that one's a greater than 0 one, where you get 2 points of intersection, just because that's the way it seems it's going. Yes, it was. It says 0. I think I've got 0. Yes, I've got 0. I got minus 15. And the one I didn't do was 9. Now, this is what the graphs look like then. This is the tangent one. This is the one where the discriminant was 0. And you can see I've got this tangent. Just touches at this point. Didn't ask me to find the point. This one, the one I didn't do, you got 2 points of intersection according to me, because the discriminant was bigger than 0. Notice there they are. Just crosses both places. And this last one doesn't touch at all. Misses. Too low. So there's no points of intersection. Finding k values. Now these come up more than probably they should. A curve has this equation. Find the values of k for which the line y equals k minus 4 is a tangent. Ah, it's a tangent. Tangent means one solution. Just been talking about that. And that means the discriminant is 0. So if we just look at this, what's our equation? It's x squared plus x. And notice it's y equals that, and then y equals something else. So we can just set them equal to each other, can't we? Kx minus 4. We just want to move everything over. We always do the same thing, x squared. Now I've got a plus x, but I'm going to take away this kx. So you might think of this as we've got 1x here now. If I take away that, I'm going to end up with, and this is a slightly weird bit, 1 minus k, lots of x. So just get your head around that. I've got 1x there now, and the kx move over. It was a positive number x now, it moves over, becomes a negative, and negative k. And notice it's best to put them together. Minus 4 becomes a plus 4. Equal to 0. So that's the slightly weird thing about this. It's better to put them together into one thing, or else you can't describe b properly. So what's a? A is 1, b is this rather horrible 1 minus k, and c is 4. Now, b squared minus 4ac then, let's do it. The discriminant is b squared minus 4ac, and it's not very nice, it's 1 minus k squared. Again, it's in the double bracket effectively there. Minus 4 times 1 times 4. Let's see. And critically, because it's got a tangent, the discriminant is 0. So I can write this equal to 0. Now it's not always 0. You have to be a bit careful. 1 minus k all squared. Well, that's 1 minus k times 1 minus k. 4 times 1 times 4 is 16. I bet it's easy. Equal to 0. Let's multiply this out. I get 1. I think minus a k minus another k minus 2k plus a k squared. Minus 16 is 0. I'm going to go up here. So what now? Well, let's rearrange it. I've got k squared. That's that one done with. Minus 2k. That's okay. And I've got 1 take away 16. That's minus 15 equals 0. Alright, that factorizes quite nicely. I get k minus 5. K plus 3, again you can chuck that into a calculator if you wish, and therefore k equals 5, or k equals 3. It does say find the values for which this is true, and there you go, I've done it. K equals 5 or k equals 3. Or one of them, minus 3, I nearly made a very bad mistake, plus 3 becomes minus 3, and now that's right. Now we're not quite finished yet, I've got one more example to do for you in class, but then we're going to play around with exercise 5b during the lesson. So I hope that makes sense, and we'll carry this on next time.